Alright, so simplified down, I got -4 square root of 5.
That is correct. Good. All right. All right. So you're going to send over some more problems we can look at.
Yeah. Alright, here's the next set of problems with number 2.
Okay. All right. So more of the same here. Sort of the same. Let me actually look at them or make that
Yeah,
comment.
only I think the only
Yeah.
difference is here they're both it's already put in like the radical over radical, so
All right. Yeah.
it's
The last one has a small little wrinkle in it, but you still do the same thing. You're just multiplying the top and bottom by the root. Now, and it's a root times a root. It stays inside, and then sometimes you just can't do anything with it. Um,
q
so,
squared of p squared of 3
and I
e
haven't done
square root of
this yet,
7
but
over 3. For example,
mm,
for number uh for the first one in number 2, you would multiply it by square root of 3 over square root of 3 to get the denominator.
right. Square root of 21 doesn't reduce, so it just becomes square root of 21 over 3. And um, you you can write it as a fraction like 1/3, but it's up to you. It's not necessary. Um, Now the next one is basically the same. Square root of 5 over the square root of 11 ends up being the square root of 55 over 11. And what you're looking for, eventually you might see one where the root does reduce, but none of them have been, you can reduce so far.
Alright,
But
next.
the next one does. The next one is square root of 2 over the square root of 6. When you multiply the top and bottom by the square root of 6, it is the square root of 12 over 6. But the square root of 12 does reduce. And that's where you have to use your prime factorization, prime numbers, build a factor tree. So like 2 and 6, 2 and 3, you're looking for pairs. For each pair, that number comes out. So the top becomes 2 square root of 3 over 6. And again, you can only simplify outside the root. So 2 over 6 is 3 on the bottom, square root of 3 over 3.
Alright,
All right, now the next one is much like the previous one. I guess it actually works out a little nicer. Why
this
don't you
one you would
try the next?
multiply, so
Yeah, why don't you try this one on your own and see what you come up with. We can talk about it if we need.
I got 1/2.
But you're multiplying by the square root of 12, right? Top and bottom.
Yeah,
Okay. Oh, I see. I see. Yeah. Okay. I see what you're doing. All right. Sorry. Yes, it is 6 over 12. I was expecting some to
yeah,
reduce.
because I
That is
divided
correct.
by 6 on the top and the bottom,
Yes.
so yeah.
Yes. So you may be asked to eventually reduce the roots. Uh, it's I don't know. You may or may not have I don't know. I mean, these probably all lead into whatever you're doing next, which is quadratic formula, is my guess.
All right. So the next part is where they get into like the imaginary numbers,
Yeah.
like a plus bi platform.
Okay.
So
As usual, if you want to send some over, we'll look at them, or I can make some up like them if you need, but
a take a screenshot. So this part of it has, I think, six problems. So one by one.
neat. Okay. So, oh, there it is. Yeah.
So in
Oh boy.
particular in this one, the ones that I don't really get is for if we could go maybe over like the fraction ones, then the those two, and then maybe the ones that are 2 over 7 minus 5i and 5i over 3 plus 4i.
Yeah. So, okay, if we look at this one first, or do you want us to do the 2/7 minus 5i
Yeah, the
first?
other one's fine.
Okay. So there's this thing called a conjugate, which should have been explained in class, but what it is I'm going to give you the conjugate and we're going to talk about why it's the conjugate. So notice that the only thing that changes is the operator, plus to minus or minus to plus. Nothing else changes. So even if it were like -3, it would be a -3. The plus is what changes to a minus.
So
Is
only
that
the
okay?
sign of like the I changes.
Yes, it's supposed to be A plus BI, A minus BI. So you're right. In front of the I term is what changes. Because you'll occasionally see them out of order and you do have to reorder it to make that. So that's
So they
good.
can
So you
ask
multiply
it
the,
like so there could be a question where it's 4i minus 3 or
yeah, and
5i over 3 4i minus 3 or something like
yeah,
that.
and you'd have to know that the conjugate is -3 minus 4i, which may not be obvious unless you rewrite it.
So in that case, you just had to rewrite it to the correct
Yes,
form and then
always a good strategy to rewrite. Um, okay. If that's clear, then it comes down to foiling. Okay, so the what's nice about the conjugate is when you multiply by the conjugate, it it should always give you a whole number. So if we look at the bottom first, and with FOIL, we get 9 minus 12i plus 12i minus 16i squared. And notice that the I terms cancel in the
so
middle
the
here,
middle I terms cancel and isn't it
right?
at the last one you take the positive of the
Yeah. Well, I squared becomes -1. So on the
yeah,
bottom, it's 9 minus 16 times -1.
which becomes
9,
16.
yes. It's good to write it out the first few times. So it becomes over 25. In the top, you're distributing this 5i to both of these. So it's
15i.
15i minus 20i squared. Same thing. 15i minus 20 times -1. Running out of room, so I'm going to come down here. And then you reorder it. So it's 20 plus 15i over 25. And then very important, it will say somewhere that you have to write it as a plus bi, which means that you write 20 over 25 plus 15 over 25i. And you do have to reduce. So this would be 4/5 plus 3/5 I, like that.
Got it.
Why don't you try the next one? on your own. It's slightly easier in my opinion because there's no I in the top. But why don't you try this one? The conjugate here, which you already probably know, is 7 plus 5i, like that. Just go and give that a try. Let me
All
know if
right.
you have any questions.
Uh, so I got 14 over 74 plus 10 over 74i.
Okay, really close. You can reduce both of these fractions. They're both divisible by 2. So that's 7 over
Yeah.
37 plus 5 over 37i. Really good. Okay, so I mean, we don't need to do them, but you oughta, I mean, you ought to be able to do, the first couple here. So I'll just make a quick comment on this one, and then we'll do one more of these. So the comment here is that make sure to write it out as the product of two binomials and then FOIL when
Like
you
it's
do this.
squared has the whole squared, so that means it's the whole binomial squared.
Yeah.
And then
Well,
from there
let's
you just do FOIL, and then she
yes.
also made a comment in class that the I imaginary number can never be squared in the final answer. It can always be like um
It's only to the power of 1 or
yeah.
non-existent. Yeah, we'll cover that in a moment. But let's move to the next one. This one's important that you be able to do here. So it's the same as the others, it's just more work. You still multiply the top and bottom by
Conjugate.
the conjugate.
Oh, but then you get on the top you get like a quadratic almost on the top.
Yeah, so on the bottom here, you end up getting 49 plus 9. So what you'll eventually do is recognize this is a minus b, a plus b, and it becomes a squared minus b squared. But because it's I, it ends up always being a squared plus b squared, essentially, because the b is part of that part of the I. You'll see that if you do this. Now, I'd like you to FOIL the top.
All right, I got actually I think I can simplify this. I got 20 I feel like I can simplify this, but I got 28 over 58 plus 32 over 58i.
Yeah, just give me what do you have the
Oh
foil
yeah,
top?
the foil I got the final foil I got 28 plus 12i minus 14i minus 6i.
And what is that reduced to?
28 plus 32i.
Okay, we got a different, like you said all the right things. You get 28 plus 12i minus 14i minus 21i squared.
Oh
That's where I
wait,
think we're, that's,
wait. I think I
sorry,
added the
sorry, minus 6i squared. I don't know what's going on.
I put minus 6i plus also I added the two instead of subtracting them.
Yeah, so this becomes positive 6. So it becomes 34 minus
Oh,
2i, like that.
actually, that's what it but it just added the two middles instead of
And
subtracting
then
them.
you typically can reduce, like it's normal that there's a, so this is 17 over 29 minus 1 over 29i, like that.
That
So let me have you try this foil problem. The one it's the foil is the one that's really just, that's the hardest one here. This is the middle right. Why don't you try this one for me? Um,
okay.
before we move on to something else, just to see if you got that.
All right, I got 33 minus 13i.
That is correct. Okay. Are there any others in that grid of 9 that you want us to look at? The ones we didn't do are adding and subtracting, which is like combining like
Yeah.
terms.
Yeah, she talked
Um,
about that in class where it's just combining the i's and the real number, the imaginary numbers into real numbers, combining the like terms. Yeah, I think I got that. All right, so number 4 placed into the chat. There's a couple of questions to the chat now.
thank you. Got it. Let me just snip that in to my other screen here. Good. Okay. Oh boy, so quite a bit to talk about here because there's ways to do this wrong and ways to do this right. And there's even sometimes discussion on social media about some of these questions. Like teachers actually post things like, why doesn't this work? And we'll just try to do it correctly. So the first thing is you always evaluate the root first. Do not multiply like you'll see in number 2. You have to evaluate the root first. So this right here is the square root of -1 times 49 So the square root of -1 times the square root of 49. This is I, and this is 7. So the answer is 7I. And it is totally okay to go to that first. Totally okay.
Oh yeah, because this would be -1 for -1 is
So what some
49.
students do is they say, okay, yeah, this is 5I. That's fine. That's totally fine. Like you just know that whenever there's a negative, there's going to be an I with it, and you take the square root. So this is 3 plus 7I plus 4 minus 5I. And this is just a combining like term. So it's 7 plus 2I, like that.
Got it.
Okay, so really nothing weird about that. But the next one requires you do not FOIL first. You have to do what we just talked about, which is reduce the root first. Do not FOIL first. Do not FOIL yet. Okay. This becomes 5 minus 6I, 2 plus 8I. And now you can FOIL. Okay. The reason
Got
is the rules in the complex domain are not the same as the real domain, which is why this often is a question you see on these groups, Facebook teacher groups, etc. The rules are not the same in the real and the complex domain. So that's why you have to do it this way. Do not FOIL. Now you can FOIL, but you have to wait. So go ahead and FOIL that and let me know what you come up with, please.
All right, I got 7 plus 2i.
For FOILing,
Wait, wouldn't, oh, wait, never mind.
yeah, you combine like terms. Take a moment there. Um,
Uh,
well, I'll be right back with you. How are you doing on this one? All right, you sent over a message. What's going on here? Here, okay, I got it. Hey, Karthik, yeah, thanks for letting me know you're back. Sure if you're still
Yeah,
muted.
so I finished foiling it. I got 58 plus 20i.
Good, good. All right, excellent. Okay, so that's good for that. So why don't you try the third one on the top row on your own, see if you have any issues. It's the same setup as the previous problem. You want to reduce the roots first and then foil. How are you doing on this one?
Oh yeah, I'm sorry. Um, Wait, so does it matter what order you write it in then if
You,
you
you,
put
you- your your final answer needs to be A plus B die. Now how you get there is up
But
to you.
for the first step for example, where you put 1 minus 3i and then 2 plus 9i, does it matter if you put like 2 plus 9i first and 1 minus 3i second, or?
You'll get the same answer.
Got 29 plus 3i.
That's correct. Good. Good. Okay, so you've got that down. The only other ones that I guess could be somewhat interesting would be the two on the bottom row in the left, but they're just combining like terms. The one on the lower right, you've actually done a couple of because you've done. Let me make a comment here on this. I should be snipping them in here. So the one on the lower right, we did earlier, contributing in. No big deal there. This one's combining like terms. This one here, you're distributing the negative into both. There's nothing really new on those. If you want to, we can work some of them out, or if you got some new stuff, we got some time as well.
Yeah.
What would be left? What would be best for you for what we got time?
Here, let me. Let's go over these two questions here, like put them in the chat. They're part of number 5. Find the values of x and y that satisfy the equation.
Yep. Yeah. So you're setting like term equal to like term here. This is kind of you see this occasionally on a standardized tests. So it's like you set the part with the I, let me do it with the operator. The I part equal to the I part, and then the non-I part equal to the non-I part. So you have minus
So
3x equals
real equals
9.
real, then not
Yeah.
imaginary equals imaginary.
And that's the pure pure definition. But it's just in words, you just set the part that looks the same. So um the eyes don't cancel, you're just not using them as part of the
So you're not using them as a
analysis.
variable.
Yeah. I mean, but you don't not canceling them. They're just like you said, it's the real part, the imaginary part. So because the imaginary part is times I. It's just a coefficient. So anyway, you get y equals 2, x equals -3. I think the hardest thing is just to make sure you get the operator to go with it. You know, I part with I part, non-I part with non-I part. And you do this over and over again in math, science, and engineering. So it's a good skill to be able to have here.
Wait, would you add the i's back in the final answer for the imaginary part?
You're solving for x and y. You're not
So,
actually rewriting them.
so you
So like
sort of kind of negate the imaginary for kind of for the
you
second
can
part when you equal it to 2y.
you're not putting, yeah, I mean they do go away. They're not canceling though. They're just it's like the coefficient equals the coefficient.
Got it.
All right, so we should look at this next one. Again, probably good to like circle or color code, but this one says -5xi equals 35i. And then same with the other, like 20 and 1/3 y, 20 equals 1/3 y, like that. So you can solve each of those for x and y.
If I, um, got x equals 7, and for the y, it would be y equals 60.
X should equal -7 though.
Oh, yeah, yeah, right. I think I forgot to put a negative, but yeah, it could be negative 7 and so 60.
Okay. Good. Good. Something more like that, or what else is on the list
Um,
there?
so the other ones are simplifying from the radical or radical times radical here. Let me put them in the chat. Get a couple of these. Um,
Okay. Yeah, again, like we could look at one like we've kind of already talked about a few of these, but you want to simplify the radical first before you do anything else. So like the good example in the middle bottom there. This first one is 6i. No big deal there. The second one is I times the square root of 40. Square root of 40, you have to come over here and reduce here. 2 and 20, 2 and 10, 2 and 5. So it becomes 2 square root 10, but that I comes down with it. So you end up 2i squared 10, like that. And then you do multiply the i's together. So you get 12i squared, square root of 10. And then I squared is -1. So it's -12 square root of 10. Like that. Very, very important that you reduce the root first. Don't multiply the numbers on the inside. Reduce the root first.
got it. Right. So
Any questions before we close out here?
okay, so then that'd be -12 square root of 10.
Yeah.
Got it. So yeah, because y squared is right.
Yeah, just a
I
quick thing
squared.
here. Quick thing here is like these are like one of the ways you can always do it is make it I squared to 625, I squared to 90. Like whenever there's a negative on the inside, you just pull out
Yeah,
that
there
as
you
an
already know
I,
there's an I in there because of
and
I
then you
set
just
up a
proceed
negative.
like you normally do. So,
Got it. And then you just had the I at the end.
well, maybe if you're multiplying, well, yeah, in these cases, yeah, but if you're multiplying, you get an I squared and so on.
Yeah.
Okay, there's more to talk about, but not today. So we're going to stop here. for the lesson.